Welcome students, welcome to Poor Academy. I am Ashish. Today we will discuss conditional probability part 3. I have already made video on part 1 and part 2 on conditional probability, and there I have discussed some problems, some easy problems, and some topics which are related to conditional probability. In this video, I will discuss mainly the properties of conditional probability and will solve some good problems. So first of all, those who have not yet viewed the conditional probability video part 1, part 2, please watch those two videos. Then view this video so that you can understand. Before we go into straight into the problems, we have to learn some properties of conditional probability. There are 4 properties. So what is this? Number 1, the probability of sample space. S stands for the sample space. Probability of sample space when F has occurred. And event F has already occurred, then what is the conditional probability of the sample space? So first we have to intersect sample space and F. So probability of S intersection F. So intersection of sample space and any event F is F itself. F divided by conditional probability of F. So F by F 1. So its probability is 1. The conditional probability of event F when F has occurred. So probability of F intersection F is equal to F, and probability divided by probability F. So F by F equal to 1. And C, probability of A union B when F has occurred. That is, conditional probability of A union B when F has occurred is probability of A when F has occurred plus probability of B when F has occurred and minus probability of A intersection B when F has occurred. You know A union B equal to probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. So similar way, if F has occurred, the probability of A by F, probability of B when F occurred minus probability of A intersection B when F has occurred. And D, probability of A intersection A complement, probability of A complement when F has occurred, that is 1 minus probability of A when F has occurred. This is very important. You will get some direct question from using this property. Now note, what is note 1? Probability of A intersection B. The probability of A intersection B, we learn that probability of A when B has occurred equal to probability of A intersection B when B has occurred. So probability of B will be divided, or I can say probability of B when A has occurred equal to probability of A intersection B when divided by probability of A. So probability of A divided A by when B has occurred, this when probability B has occurred divided by probability B, and probability B when A occurred is intersection of probability of intersection A intersection B and probability of A. Now you see from this that probability of A intersection B is equal to probability of A when B occurred into probability of B. So that is written probability of A intersection B equal to probability of A into probability of A intersection B equal to probability, this part, you see this part, probability of A intersection B equal to probability of from this we get probability of A intersection B equal to probability of B into probability of A when B has occurred. So this portion, the probability of A intersection B, this equal to this probability of B into probability of A when B has occurred, and from this same thing we will get probability of A intersection B equal to probability of A into probability of B when A is occurred. Just multiply. So probability of A is either this or probability of A into probability B by A. It is simple to memorize. If probability of A is there, A would be multiplication would be with probability of B when A has occurred. One A will be up, one A will be down. Or probability of B into probability of A when B has occurred. Clear? And probability of A intersection B intersection C. So this equal to probability of A. First, there is a probability of intersection of A, B and C. The first A will occur, the probability of occurrence of A. Then B will occur, the probability of B when A has occurred, because first A has occurred. So this into probability of B when A has occurred, and last probability of C when A and B has occurred. This is symbolically written: probability of A into probability of B when A has occurred, probability of C when AB has occurred. Clear? Now we will do some problems. So problem number 1, given probability of E is 0.6, F is 0.3 and probability of E intersection F is 0.2. Find probability of E when given F, that means when F has occurred. So number 1, A, probability of E when F has, probability of E when F has occurred, that is probability of E intersection F divided by probability of F. So it is given probability of E intersection F 0.2 divided by probability of F. Probability of F is 0.3. So it is 2 by 3. So A is probability of E when F has occurred. Always first intersect, then which has occurred. If the probability of F or number of element of set of the event F, and here number of element of E intersection F. Then B, probability of E F when F has occurred. Same thing, first intersect of F and E, E and F or F and E, same thing. So this is equal to probability of E intersection F divided by probability of E. So probability is 0.2 divided by 0.6 equal to 2 by 6 equal to 1/3. Now see, probability of E complement given F complement. So this equal to probability of E complement intersection F complement divided by probability of F complement. So by De Morgan law, you know probability of De Morgan law say A complement intersection B complement equal to A union B complement. This is De Morgan law. De Morgan law of probability. So using this probability of A intersection, probability of A complement intersection B complement equal to A union B complement. And in case of A complement union B complement, it will be A intersection B complement. So using this property, I will get probability of E union F complement divided by probability of F complement. So probability of A union E union F and its complement. So probability of E union F equal to probability of E plus probability of F minus probability of E intersection F. The probability of E, you know, probability of E, probability of E is 0.6 plus 0.3 minus 0.02 equal to 9 minus 2, 0.7. Now here is probability of E union F complement. The probability of E union F complement equal to 1 minus this, 1 minus 0.7 equal to 0.3. So I can now put the figure. This equal to 0.3 divided by probability of F complement. If probability F is 0.3, so F complement is 1 minus 0.3 equal to 0.3 by 0.7 equal to 3 by 7. Here it is to some extent it is complicated. Now use the De Morgan law, it will be easy. Problem number B. If probability of A is 0.8, B is this, and probability of B when A occurred 0.4, find probability of A intersection B. So clearly using this and this we will get A intersection B, because probability of B when A has occurred equal to probability of A intersection B divided by probability of A. So probability of A into probability of B A equal to, it implies that probability is equal to probability of A intersection B. So probability of A intersection B equal to this into this. I have written this. So probability of A intersection B equal to probability of A. Probability of A is 0.8. Probability of 0.8 into probability of B when A occurred 0.4. 0.4 equal to 0.32. Clear? A is done. B. Probability of A when B occurred. Probability of A when B occurred equal to probability of A intersection B by probability of B. So probability of A intersection B just calculated 0.32 divided by 0.5. 0.5 half. That means it would be 0.64. C. C. Probability of A union B. Probability of A union B. probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. This is equal to probability of A 0.8 plus probability of B 0.5 minus A intersection B minus 0.32. So this gives 1.3 minus 0.32 equal to 0.98. So 0.98 is the probability of A union B. D is probability of A intersection B complement. So you see the area AB, probability of A intersection B complement. B complement means outside B, and A and its union intersection A intersection B complement. So A and A complement intersection is this crescent, this portion, just this crescent, this portion. So you can easily calculate it from probability A minus probability of A minus B. Total probability of A minus probability of A intersection B. So you will get this area. Probability of total A minus probability of A intersection B. So this equal to, I can write probability of A minus probability of A intersection B. So probability of A is 0.8 minus intersection B 0.32. Probability of A is 0.8 minus minus intersection B this. So this equal to 0.48. There is a correction, 0.48 is the answer. Probability of A intersection B complement. You please correct the answer 0.48, not 4, 0.48. Now E, probability of A complement intersection B complement. Again using De Morgan law, though this equal to probability of A union B complement. So A union B complement, A union B just I have calculated, A union B. A union B complement equal to 1 minus probability of A union B. So this equal to 1 minus probability of A union B. A union B is 0.98 minus 0.98 equal to 0.02 is the probability of A complement intersection B complement. So I think you have understood this problem. You go through the video part 1 and part 2, then it will be easier for you to comprehend the problem. Problem number 3, evaluate A intersection B, A union B. Probability of A union B is probability of A equal to probability of B equal to probability of 5 by 13, and probability of A when B occurred 2 by 5. So what is evaluate probability of A union B? So for A union B, probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. It is clear. So I know what is probability of A. Probability of A equal to 2 probability of A is equal to 5 by 3. That means probability of A equal to 5 by 30 divided by 2, 5 by 26. And probability of B equal to 5 by 13. So what is the probability of A intersection B? So if we calculate A intersection B, the problem is easy. So I can put probability of A equal to 5 by 26 plus 5 by 13 minus this minus probability of A intersection B can be calculated as probability of probability of B. The probability of B into probability of A given B. This probability of A intersection, because if you calculate this equal to probability of A intersection B divided by probability of B, because B has occurred. So probability of A intersection B, probability of B into probability of B A by B. One B would be in up position and one would be down. A divided A by B, not divided by, symbolically one would be upper portion and B would be as a denominator. So probability of A intersection B, probability of B means 5 by 13 into probability of this is 2 by 5 is equal to 10 by 65. So minus 10 by 65. So LCM is 130, I think. 130. LCM is 130. So 25 plus 50 minus 130 minus 20 to 20. So this gives 55 by 130. So divided by 5, 11 by 26. This is the answer. Probability of A union B. Clear? Now a die is thrown 3 times. A die is thrown 3 times. What is the probability that 4 appears on third toss? 4 appear on the third toss, given that 6 and 5 appears respectively on first 2 tosses. So first toss will get 5 and second toss will get 5. 5 it is given. Then in first toss we got 6 and in second toss respectively we got 5. Respectively, not 5, 6 will not our favorable case. First 6 and 5 occurred, and what is the probability of 4 appear on the third toss, given that this has already occurred. So this event we have to consider this event as B, and what is the probability of required 4 at the third toss, we take this event as A. Now let us solve this problem. Now see, we have considered event A is equal to event A equal to 4 appears on the third toss, and we consider B that 6 and 5 occurred respectively. That means in first position 6, then second position 5 appears on the first 2 tosses, and event A is 4 appears on the third toss. So what are the possible ways? What are the different number of ways? So let us assume when we toss a die 2 times, what are the different outcome? 36 outcome like this: 1 1 1 2 1 3 1 6 1 2 1 2 2 3 6. But if you and 6 1 6 2 6 6, 36 number of outcomes. So number of sample space for tossing 2 die is 36. But in case of tossing 3 dice, a die is thrown 3 times. So if a die is thrown 3 times, what are the possible number of outcomes? There be, if I get this is the outcomes of sample space of 2 die. So if there is a 3 dice is tossed, so in the third position either it will come in all, if you add 1 1 1 1 1 2 1 1 6 1, and in all the cases you add 1 at last, then there will be another 36 cases. And if 2 appears at the third position, then another 36 outcome. And if 3 comes, you add 3, another 36 outcome. And if you add 4, if you add 5, if you add 6, you will get another 36 cases. So total number of cases in that case, tossing or throwing a die 3 times is 36 into 6. That means 216 is the favorable cases. The total number of outcomes, not favorable, total number of outcome. Because if you one may come with these 2 pairs, all pairs 2, 3, 4 and so on. Now event A is the event that appears 4 appears on the third toss. So like I have considered 1 36 times, 2 36 times. So 4 will appear in how many times? If you add 4 4 4 4 4 4 4 4 4, so 4 appears on the third toss. How many cases? 4 appears in the third tosses, 36 cases. So in this case, the number of elements of set A that 4 appears on the third toss is 36. And now which has appeared? B. What is event B? 6 and 5 appears respectively on the first 2 tosses. The first 2 tosses 6 and 5 appears. So what is the set B? Set B 6 5 occurs in the first 2 cases. So 6 5 1, this may be one case. 6 5 2, 6 5 3, 6 5 4, 6 5 5, 6 5 6 5 6. These are the total outcome. That means NB equal to 1 2 3 6 5 4 5 6. So this is the 5 and 6 appear respectively on the first toss, and then third case may be 1 2 3 4 5. Now what is required? We are required to calculate A when B has occurred, probability of A when B has occurred, probability of A when B occurred. So probability of A intersection B by probability of B, or we can calculate it by number of elements, number of A intersection B by number of elements of set B. So this is A, this is A. Now I can write, if 4 we add, this becomes A, this is A. So if it is A and if it is B, what is the intersection between A and B? You see, the intersection is only this element, 6 5 4, 6 5 4, 6 5 4, 6 5 6 5 4. Just before this element it will be 6 5 and 4. This is only the common element. So common element of A intersection B is number of elements. If you have considered, number of element is only intersection 1, because that is 6 5 5. I can write here A intersection B equal to intersection B is 6 5 4. So N A intersection B equal to 1. And now the you have got numerator and denominator is either this or this. So probability number of element of set B. Set B element is 6. So answer is 6. This is divided by 6. So answer is 1 by 6. or if you want to calculate probability, so with the help of probability, this formula, so probability of A intersection B by probability of B, probability of A intersection B, probability B, that is probability of A B. You can apply this formula. So what is the probability of A intersection B? A intersection B probability, number of cases 1, this is 1, so out of 213 case, 36 into 6, 216 case, sorry, 216. So probability of A intersection B is 1 by 216 divided by probability of B. Probability of B, number of elements is 6, so probability is 206. So answer would be 1 by 6. So in either case you apply this formula or this formula. Sometimes it is easy, sometimes it is easy, which you may apply depending upon the problem. So I have calculated in both ways. So the intersection is one case, 6 and 5 occurred, and occurred with 4. So it satisfies both, that 4 appears on the third toss and 6, 5 appears in the first two tosses. So one case is, and total number of B has occurred, this B has occurred 6 and 5, so there are 6 cases. B occurred, 6 and 5 occurs with 1, 2, 3, 4, 5, 6. So 1 by 6 is the answer. Clear? Problem number 5. Mother, father and son line up at a random for a family picture. There is a family picture and mother and father are positioned in different fields. What is the probability that the son is at one end? Son is at either left end or right end. Given that father is at the middle. Father is at the middle. There are 3 persons, mother, father and son. What is the probability that son is at the one end, either this end, left hand or right hand, given that father is at the middle? So if father is middle, it is obvious that either mother and son would be either this end or this end. So the probability, I can say, it is always 1, because given that father is at the middle, so son would be always either at this left hand or right hand. Right end. So probability of this is always 1. So let us calculate. What is the sample space? Sample space, if they are lined up in a for picture, so if I consider son, father at one end, father, mother, son, or father, son, mother. Another may be mother, father, son, or mother, son, father. Another son, mother, father, son, father, mother. There are 6 number of such cases. Sample space. This is the sample space. What is the probability that son is at one end? Sun is at one end. So let us consider a event. Sun is at one end. So what are the element? Sun is at one end. Sun, this F M S. Sun is at one end. Sun is at one end. M F S. S. Sun is at one end. No, sun is one end at this end. Son, mother, father. Son, father. These are the elements when sun is at one end. Sun, this end, and left hand. So there are n equal to 4 such cases. So probability B is given that the father is at the middle. So B equal to father at the middle. So if father is at the middle, what are the favorable cases? Elements. Father is at the middle. Father is at the middle. MFS. Father is at the middle. Father is at the middle. SFM. So NB equal to 2. NB equal to 2. Now what is the intersection of A and B? A and B intersection. What are the elements? A and B intersection, MSF, MFS, SFM. Two elements, MFS and SFM. There's a SFM. These are the two elements. That means NA intersection B equal to 2. And now what is required? What is required? It is required calculate the probability that sun is at the one end. So what is the probability of A given that father is at the middle, given that B? So we know we can calculate N A intersection B by N B. The probability of A in N A intersection B is 2, and the probability of B is also 2. So 2 by 2, 1. So, or you can calculate this way: probability of A, 2, total sample space 6, 2 by 6 divided by 2 by 6 equal to 1. Both ways same answer. It is interesting. So apparently we could calculate the probability 1, because if father is at the middle, the sun must be at one end, because the total number of person is 3. So probability is 1. Clear? Problem number 6. A fair die is thrown. Fair die is thrown. So it is thrown, you will get either 1, 2, 3, 4, 5, 6 element. So E event E is 1, 3, 5, and event F is given 2, 3. Event G is given 2, 3, 4, 5. Find P, probability of E event when F has occurred. So we have to calculate E intersection F. So we have calculated E intersection F, and probability of EF when E has occurred. Again F intersection E, that means E intersection F. So this will solve the purpose. Probability of E when G has occurred. So required E and G, intersection of E and G. So E and G we have calculated, E and G intersection, and then again probability of G when E has occurred, we require probability of intersection G and E. It will solve the purpose. Then probability of E union F given G. So we require E union F intersection G. E union F intersection G. E union F intersection G. And here we require E intersection F intersection G. E intersection F intersection G. So let's calculate one. E intersection F. E intersection F. This is E and it is F. So E intersection F is 3. So 3. So only one element. E intersection G. This is E and this is G. E intersection G, 3 and 5. 3 and 5. Then E intersect union F. E union F. 1, 2, 3, 5. 1, 2, 3, 5. Now E union F intersection G. So E union F this and G is this. So its intersection is 2, 3, 5. 2, 3, 5. E intersection F, E intersection F, E intersection F, this 3, and A intersection G, So this intersection G is 3. Now we calculate the probability one after another. A probability of E when F has occurred. So this is equal to probability of number of element of E intersection F by NF. So NF A intersection F is number of element 1. So 1, and number of element of F this number of element of F is 2. So the probability is half. Now B, probability of F when E has occurred equal to N probability of E intersection F, and now probability of N of E. So intersection 1 and E probability of E is 3. So 1/3 is the answer. Now A is done. B is this is part of A. This is also A. So B is probability of E when G has occurred. Another probability of G when E has occurred. The probability of this is equal to N E intersection G and by N G, and now it is also N of E intersection G and N of E. Now first one, probability of E and G, N intersects number of element E intersection E and G, and its number of element E and G intersection, the number of element is 2. So 2, and number of element of G is 1, 2, 3, 4, 4. That is probability is half. And next, now E and G is again 2, and number of element of E, number of element of E 3, 2 by 3. Clear? Now C is asked probability of E union F when G has occurred. So this is equal to number of element of E union F intersection G. So probability of E union F intersection G equal to N of E union F intersection G by NG. So E union F intersection G, number of element 3, and total number of element of G is 4. So 3 by 4 answer. And last, probability of E intersection F when G has occurred. Again same, N E intersection F intersection G by N G. So E intersection F intersection G is 3. That means number of element 1, and G number of element 4. So 1 by 4 is the correct answer. It is very easy. Okay, last problem. Last problem of part 3 video on probability, conditional probability. So in a school there are 800 students. In a school there are 800 students. Okay, 40% of the students are girls. So 60% are boys. Obviously, out of the total boys, 10% read in class 12. So total out of the total number of boys, only 10% reads in class 12. In your class, a student is selected at random. A student is selected at random. What is the probability that the student reads in class 12? What is the probability that the student reads in class 12? It is given that he is a boy. If he is a boy, what is the probability that he reads in class 12? So let A is the event that probability that the student reads in class 12. The probability A that student reads in class 12, and B, student is a boy. Okay, what is the A student is selected at random, and what is the probability that he reads in class 12, given that he is a boy? So we have to calculate probability of the student reads in class A, that given that the student is a boy. So this I can calculate n number of element of A intersection B by n B. So let us calculate one by one. So what is the total number of boys? So total number of boys in the class, how many boys are there in the class? So total there are 800 students. So boys 40%, girls, so 60% boys. So number of boys equal to total 60% are boy out of 800. So 800 into 60%, 480 are the number of boys. And out of the total number of boys, out of 480, 10% read class 12. So boys who reads in 12 equal to 10% of this, that means 48. 48, how will get 48? 480 into 10% equal to 48. So 48 is the number of students who reads in class 12. So what is the probability of the student is that the student reads in class 12, given that he is a boy? So student A intersects A when B has occurred. That means N A intersection B by N B. N B means probability that B means the student is a boy. So number of boys, we know number of boys, denominator it will come for 840. 480. So what is the intersection of A and B? A means that the student reads in class 12, and B is number of student, the student is a boy. So intersection of boy and student reads in class 12. This is the intersection. A means student reading in class 12, reads in class 12 and boy. So what is the intersection? Boy and student reads in class 12. So is 10% 48? 48 is the number of student, number of boys who reads in class 12. So it is intersection of boy and the student who reads in class 12. So the numerator NAB is 48. So the probability is 1 by 10, or you can say 0.1 is the 0.1 is the probability. Okay, so first is probability of B. B means number of it is a boy. So what is the number of boys? Number of boy is who reads in number of boys is 480, and now intersection of boy and the student who reads in class 12. So this is 48. 10% of boys are in class 12. So intersection is 48. So 48 by 480 is 1 by 10 is the probability. So I have completed video part 3 on MCQ on conditional probability. I hope you understood up to part 3 video. I request you again and again to view part 1, part 2 and part 3 sequentially. Then you will be able to understand. Next I will make a video part 4 where I will take more to some extent more important or harder problems, harder than these problems, to cover everything on conditional probability. If you like this video, you share the video to your friends, relatives, students, and you must subscribe to my channel Poor Academy. Thank you very much for watching this video. I hope you will view the part 4 video also. Thank you very much for watching.